Hello and welcome to Fixing the Future, an IEEE Spectrum podcast where we look at concrete solutions to some big problems. I'm your host, Glenn Zorpette, Editorial Director at Spectrum. And before we start, I just want to tell you that you can get the latest coverage from some of Spectrum's most important beats, including AI, climate change, and robotics, by signing up for one of our free newsletters. Just go to spectrum.ieee.org/newsletters to subscribe. Electronic quartz watches arrived on the scene around 1970, and even today they have advantages over their smartwatch brethren with batteries that last years, not days. But the motor that drives the hour and minute hands of the watch hasn't really changed since then. Now French company Silmach is using a new wristwatch to demonstrate its advanced silicon MEMS technology with a new watch movement that's so efficient you might only need to change the battery about once a decade. Here to talk about that watch and the technology behind it is Silmach's co-CEO and Chief Sales Officer, Pierre-Francois Louvigne, and also Jean-Baptiste Carnet, the co-CEO and Chief Financial Officer. Pierre-Francois and Jean-Baptiste, welcome to the show.
Welcome.
Thank you for having us.
Thank you.
Glad to have you here. So my first question, the question that popped into my mind when I first read about your remarkable new watch motor is, why make a tiny electric motor now, at this time, for an analog watch? Aren't smartwatches taking over the wristwatch market now, the Apple Watch and so on? Aren't those the thing everyone seems to be buying?
Yeah, thank you for inviting us in this talk. Thank you very much, Glenn. What we can say is that in the quartz watch, there is this technology named Lavet Motor since more than 50 years. And if you open a classic quartz watch, you will see that there is a motor that is old technology, electromagnetic technology. And we invented at Silmach a new motor based on the most advanced technology, and that is fully compatible with electronics.
So you have a particular strategy or a kind of watch in mind that you think will grow in the future?
The point is that this technology is obviously dedicated first to the smartwatch market, because this market is ready to use these micromotors.
So you don't mean the smartwatch that that most people think of, which is the Apple Watch, which has no hands at all. I mean, no physical hands. It's just a display screen. You seem to be referring to what is sometimes called the hybrid smartwatch or the hybrid connected wristwatch. Is that correct?
Yes, it's correct. Yes. The objective is to give the opportunity to any watchmaker, including connected watchmakers, that it's possible now to use a motor to drive hands on a PCB, on an electronic board. And offering this opportunity, we think that those makers can design new watches.
So who are some of the companies that make these hybrid smartwatches?
I think the most advanced company is Withings.
Withings.
It's a French brand, and the market that they are targeting with the watch is the health market. And we believe that in this market, the people are willing to have like a classic watch, like they can say also vintage look, okay? And if you want to do that, then you need motor to drive the hands.
Physical hands.
Physical hands, yes, correct.
So Withings is a big name in this category, but there are others that are in the category, correct?
Yeah, there is Garmin. Everybody knows Garmin. Fossil also, that is a big player. But they are all looking for a part of the market. Garmin is more for sport activity. Fossil is more on fashion design. and we think it's for health.
So for listeners who might not be familiar with it, this is a wristwatch, and when you look at it, it looks like an old school, a conventional analog wristwatch. However, they often have small electronic screens that show information. And in fact, the watch can also typically connect to your smartphone. So it can gather data from your smartphone. These watches often have accelerometers or blood pressure monitors and so on in them. So they typically have a lot of electronics, because not only do they have these sensors, but they've got to have the motors. And if I understand you correctly, your motor is more compact and efficient, which gives you advantages in this space.
Yes, right. One of the big advantage of the motor is that it is very compact. Roughly, you gain 50% in volume. Could be footprint, could be weight, about 50%. So it's
50%
huge.
more room inside the watch
Yes,
case.
Yes. And as you said, effectively, in this type of watch, you have a lot of technology, very advanced technology. And now the motor is as advanced as the other function in the watch. That's the big difference now.
So tell us a little bit about your wristwatch motor. I believe you call it the MEMS box, is how you refer to it. What are the advantages that your watch motor has if you are going to integrate it with other electronics on a tiny circuit board that goes inside a wristwatch?
The very big change compared to the current technology, the Lavet one, is that the MEMS box...
So the existing motor is called the Lavet Motor.
Yeah, the Lavet Motor.
As you mentioned.
From the name of the inventor, Marius Lavet. He was a French guy in the 30s, 1936 exactly, and he invented this technology that is in each of quartz watch today, more than 1 billion of quartz watch. So this technology, it's the only one you can use so far, okay? But the motor is not coming from the electronics. So it's electromagnetic, it's like a bulky micromotors, and you have to screw the motor on the PCB, screw it. So you imagine the cost of screwing a motor on a PCB. In our case, the MEMS box is designed to be SMT compatible.
So you just use surface mount soldering technology to mount it right to the circuit board.
Yes, correct. It's like any other electronic component. You can handle it and solder it on the PCB as another one.
So, Jean-Baptiste, what are some of the advantages now with this motor? What are some of the things that you now have in your watch that you couldn't have with the old style Lavet motor?
Yes, as Pierre-Francois mentioned, it's more compact, it's much thinner, and inside the hybrid smartwatch, people have to imagine that almost half of the space inside the watch is not actually dedicated just to the micromotor as it is today. And the little sensors, all the technology, all the know-how of the brands that are developed today, they have to adjust around like half of the space already being taken by the micromotor. So it's by far the biggest part inside of the watch, and making it much more compact, about 50%, much thinner, either allows for new designs of watches where you could make much smaller watches. For example, we know that the Garmin watches are pretty bulky. Or you could keep the same design as today, but implement more technology inside of it because you have more space, or make it last longer with a bigger battery, for example, because you freeze quite a lot of space. So that's a big point. The SMT compatibility is also very interesting because as you get rid of the labor-intensive aspect of assembling a watch, you're now free to assemble it anywhere you want. You don't need to maybe go to a country where labor is more affordable. You can imagine assembling it in Europe, assembling it in the US, which is currently not possible. Also, the motor is anti-magnetic, which is interesting because the sensor interactivity can derail the current motor a little bit, or the interaction with magnets inside the woman's purse, for example, watchmakers told us, oh, that's a very interesting feature because it's a problem we have right now.
How about the energy usage and the precision of the tick marks as it goes around the face of the watch?
Yeah, that's also one aspect of it. Is first, the motor is consuming less energy also than current technology, so you can imagine having a longer battery life as well. That's why the watch we are launching with the technology can offer more than 10 years of battery on a regular battery that you can buy anywhere. And also, as you said, the freedom of movement is an important feature because the motor is pretty much electronics. You can program it, pilot it however you want. You can have it go forward, backward, faster, slower. And what watch enthusiasts are interested about is you can either have it tick, for example, the seconds like a traditional quartz watch, or you can have it make a much more fluid movement, which is somewhat of a holy grail for watch enthusiasts. So that's things that become possible with our technology that was not with traditional ones, and that's what watch designers, since we unveiled the technology a couple of weeks ago, and we will keep on doing it at CES in January.
So here's my own pet peeve about watches. When I was a young man and I did a lot of scuba diving, I actually had a watch that had tiny tritium gas markings, so it glowed all the time. It didn't need to be charged with a bright light. And I loved this watch because I could read it clearly underwater even at night. It was bright enough. And also at night when I was sleeping, if I woke up in the middle of the night and the watch was on my bedside table, I could see what time it was without having to turn a light on or anything like that. And I know that those watches can be tricky. They go dead after 5 or 6 or 7 years because the tritium half-life, they're too dim to read. But I've always wondered if it would be possible using perhaps some ultra-efficient light-emitting diode or other technology to recreate that somehow. If you had enough space for a battery and other power supplies, if you had enough room in the case, if you could create these watches, which were popular at one time. If you go back even to World War II, they made watches using radium and so on. It just seemed such a practical thing when I had it, other than the fact that it went dead. But is that more possible now, technologically, with a very tiny and efficient motor?
Yeah, clearly it's possible. I don't know if you know some of the watch coming from Timex. They have a specific patent on that. It's like a luminescent dial that gives you the opportunity to see what time is it, even in the dark, fully dark. So yes, it's possible. It's possible to combine the technology with other ones, providing such a result. Yeah.
So you mentioned Timex, and in fact, that gets me into my next question, which is, have you had interest from any major watchmakers yet in your MEMS box motor?
Yes, we know most of them. We know most of them because those companies, they were looking for the progress we made on the technology. So we have been in contact with them for more than 15 years. So yes, it's done. The particular partnership we have with Timex was based on the fact that we are a small company. We are about 30 people in France. We are in the good region for watchmaking because it's the former one. In the past, there was a huge activity in watchmaking industry. So we are in the good region for that. And there is one important partner we have that is a subsidiary of Timex in France. And this company named Fralzen is making all the small parts used in quartz movements. So it was obvious that not the compatibility, but the synergy between our very new technology and those classic parts was very interesting. And then we went to the Timex group and we decided to build a joint venture, so a common company, that is based in France, and the name is Timex. Timex, Silmach, Timex.
Timex, okay. And so in the future, we may be seeing this motor in watches from Timex or other companies.
I mean the objective of the joint venture is to sell the technology all over the world. It's not obviously not specific to Timex. They will use it in their watch, but no, it's open to the market widely.
So, but I guess another question that might be on the minds of some of our listeners is, why did it take so long for someone to harness the technology of silicon microelectromechanical systems, or silicon MEMS? That we mentioned that silicon MEMS technology has been around for decades, 20 or 30 years, as far as I know. But yours is the first to harness it for a wristwatch motor. Why were some challenges that delayed this use?
Yes, clearly what we are doing is very unique, because there is no other company or even university that is that made this development. Okay, this is very unique because in fact we are combining the MEMS technology that is very advanced. You have to go in clean rooms to manufacture the silicon, but as soon as you will finish the silicon parts, you made only a part of the journey development. Okay, you have to combine those silicon parts with more classic parts coming from the watchmaking industry, and this is what we do. We call this hybridization, meaning that we connect the silicon with classic micromechanics, and we are the only company that makes that in the world. So we have invented the motor, but we have also invented the technology for the assembly. This is completely new, and we have patent in both sectors. So yeah, you need a lot of time for developing all those steps of the technique.
Well, thank you both very much. Again, I've been talking with Pierre-Francois Louvigne and Jean-Baptiste Carnet about they're both with Silmach, and they have a remarkable silicon MEMS wristwatch motor called the MEMS box. And we've heard a lot about the promise and challenges of this watch. For IEEE Spectrum's Fixing the Future, I'm Glenn Zorpette, and I hope you'll join us next time.